In this lecture, we're going to go over the rules for making proper plots. We're going to identify the abiscate and ordinate of a graph. We're going to identify the independent and dependent variables in a problem. We're going to create proper plots. We're going to recognize the different types of graphs available in Excel and when to use each type. We're going to understand the difference between a scatter plot and a line plot, and we want to look at the concept of categorical data. So the abiscate is your independent variable, it's your control parameter, it's your x-axis. Your ordinate is your dependent variable, it's your measured parameter, and it's your y-axis. So the abiscate is the horizontal axis, and your ordinate is your vertical axis. You can remember it by x is before y, horizontal is before vertical, and abiscate is before ordinate if you think about them in an alphabetical manner. So what are proper plotting rules? So the proper plotting rules are that you label the axes. If a graph will be inside of a document, you include a caption or a title as appropriate. You choose an axis scale that allows easy interpolation. You provide guidelines as needed to help interpret the data. You use markers to represent measured data and smooth lines to indicate calculated values or a theoretical model. You distinguish data type displaying using high contrast colors as well as symbols and line type, and you include a legend if more than one data set is displayed. So axes, labels, and titles. Your label axis should include what it is, its variable, and its unit. So if your axis is time, you should say time, its variable is t, and its units is seconds. Use a descriptive title or caption within a document, information describing the problem, not d versus t or distance versus time or relationship between or as a function of. You really want to get descriptive. For axes increments, you want to scale increments that are easy to read and interpolate between. So typical increments, you can be 1, 2, 2.5, 5, 10. All of those numbers can be scaled by powers of 10 and still be easy to interpolate between. You shouldn't use unusual increments such as 3, 7, 15, 6.5. These are going to make interpreting your graphs extremely difficult. So for example, if your increment is 1, you can have 0, 10, 20, 30, 40. You can have 0.5, 0.1, 0.15. You can also do it with scientific notation. So grid lines are useful for determining information. So I'm asking on which graph is it easiest to determine the value of voltage given at time 27. On the first graph, it's nearly impossible because you have no way to tell between 20 and 30 where 27 lies. On the second graph, you have, even though you still can't figure out where 27 lies, even though you can figure out what the voltage is. With graph C, although you can figure out where 27 might be, you're going to have a hard time figuring out what the voltage is. On graph D, since you have vertical and horizontal grid lines, it makes it very easy to find points. This is because you can use the distance between points to make a scale. So all plots should have horizontal and vertical grid lines. A big point that I want to make is the difference between experimental and theoretical data. Experimental is determined in an experiment and it is measured. So you're going to show it as discrete symbols for the measurements that you have taken. Different symbol shapes should be used and different colors for each data set. Theoretical data is determined from an equation. It's calculated, so you can show it as a line, and you should use different line styles for each theoretical data set. The reason it's a line is because you can calculate it, you have an equation, you know what its value is at any point, whereas for your measured data, you only know the information at discrete points. So to distinguish data series, you want to distinguish curves and symbols for all data set. You want to use distinct dark colors for each data set. Why not? You don't want to use color only, and why you don't want to use color only is because what if someone happens to print it in black and white? So you want to use different symbols and line types. Don't use yellow or light colors because you can see here they're pretty impossible to see. You want to include a legend if 2 or more data sets are presented. You don't need a legend if it's a single data set, and it must include meaningful series names. Series 1 is not meaningful. You want to be able to, someone looking at your graph to be able to draw all kinds of conclusions from your picture. So here's an example of a proper plot that is using experimental data. You have both the horizontal and vertical grid lines are shown. You have axis labels that include the variable and its unit, and its symbol, its abbreviation. Since it's experimental data, we have it shown as points, not connected with lines. We have a scale set to reflect an increment. And we're also not putting additional unneeded decimals on there. The points are different colors and different symbols. And since it's 2 series, we have a legend here that explains, all right, the diamonds are for mass equals 100. The squares are for mass equals 250. So there's an example of a proper theoretical plot, and this is a single series. Again, our axes are labeled. We have both vertical and horizontal grid lines. Our scale on our axes are good increment size, and they don't have any additional decimal places. And since it's theoretical, we have a line, in this case a dashed line, and we don't have a legend since it's only 1 series. So what are some different kinds of plots? So a scatter plot numerically represents 2D theoretical or experimental data. It's commonly used with scientific data. A scatter plot is probably the plot you're going to make the most in your engineering career. You use a scatter plot to observe mathematical phenomena and relationships among different data sets. You interpolate or extract information from data sets, and you can determine a mathematical model for a data set using trend lines, which we will get to next week. Well, what's a line plot? A line plot visualizes a 1D set of theoretical or experimental data. It places elements evenly along the x-axis regardless of the actual step spacing in the data, which is why line plots are not typically used. You use a line plot to display evenly spaced data, visualize time series data taken at even intervals, and to display categorical data such as years, months, days of the week. We also have a column and bar plot. They are used for displaying visual types of categorical data. One axis contains increments that are evenly spaced. The other axis has discrete categories. As a rule of thumb, a column or bar graph can be used to represent the same information shown on a line plot. So if you can plot it on a line graph, you can plot it on a column or bar plot. You use a column or bar plot to display any categorical data and observe the differences between categories. For example, grades in 1102 based on each semester from year to year. You have a pie chart, a single column or row of non-negative numbers graphed as a percentage of a whole. It's typically used for categorical data with a maximum of 7 possible categories. You use a pie chart to display the categorical data as part of a whole and observe differences between categories. For example, the percentage of students that have A's, B's, C's, and so on. So those are the types of graphs that are available in Excel. Next, we're going to look at how we actually make a graph.